Now, let's look at it and said a different way. The internal rate of return, IRR. The IRR is trying to back calculate what is the discount rate that will make a series of cash flow streams, the net present value of those cash flow streams, equal to zero. In other words, previously in all three, present value, future value, and NPV scenarios and examples that we just illustrated and walked through, you were given the 15% discount rate. Now, if you are given a set of cash flow streams as well as an investment cost, what is the discount rate that will set that equal to zero? In other words, what is the return of this particular project? This IRR is a very important number because you will compare this against the cost, the weighted average cost of capital, against the cost of the funding required to come up with the cash to fund that project, and then you will evaluate it. Let's take a look at IRR, and when we get to the WACC, we'll summarize all of those key discussion points in one summary. So looking at our IRR here, the idea here is that this is the discount rate, once again, that will equate the present value of a stream of future cash flows to zero. For instance, taking a look at an example, you invest $10,000 today in a project. That is time period zero, you invest $10,000. Negative cash flow of $10,000 because it is cash out, hence the negative sign in front of the $10,000. You will project that you will receive the following cash flows over the next 4 years, and we want to figure out what is the discount rate that will equate this to a net present value equal to zero. So for instance, I have $3,000 here. I have $3,500 in time period 2, $4,000 in time period 3, and $4,500 in time period 4. This is going to be a mathematical exercise that will give you a certain amount of brain damage without a calculator or without a financial calculator or without Microsoft Excel or some comparable spreadsheet software. But this is how you solve it from a conceptual perspective. You will first take your $3,000 and you will discount it by 1 plus R to the first power. Why the first power? Because that's the first time period. You would then take the same thing for the other cash flow periods. 3,500, 4,000, and 4,500, all divided by 1 plus R, now to the second, third, and fourth power. You must now solve for R. So you must solve for R, which is the rate, the discount rate, such that the left-hand side, all of these cash flows, are going to equal the right-hand side, the $10,000 investment. Then that will mean exactly what was the return on an annual basis that you received of your $10,000 investment. As you can clearly see here, this is going to be a monumental exercise in algebra. Thank God we have the calculators, our financial calculators. You will simply enter in these cash flow periods. You will simply enter in these cash flows. You will enter in your initial cash flow, and you will have your financial calculator solve for R. How the actual calculators do this physically is they will actually put in estimates of time period R for each time period, and then they will see, okay, what is the amount. They will do trial and error, such that this will now equal that number, your initial investment. This IRR, again, is the rate that will set the net present value equal to zero. What this means is that all cash flows are going to be reinvested at the IRR. This is not always a realistic assumption. However, the assumption is that you would take this $3,000 and you'll be able to reinvest it next year at the same 17% IRR, which is what we calculated this cash flow period to be, that you invest it at that same rate going forward. That is, again, not a realistic assumption, and that is one of the flaws of the IRR. If the cash flow signs change signs, in other words, I made $3,000 this year, then I lost $1,000 next year. You may have multiple IRRs in that particular case. We won't cover that in here, but then you would use the modified IRR approach to handle that particular calculation.